Hello students, today I'd like to work with you on calculating the area of 2D shapes. We know that perimeter is the distance around an object and area is the amount of space inside an object. Area is always calculated in units squared. So if we look at this rectangle that we have right here, we can calculate the area very simply by counting the squares that are inside. So if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we know it's 10 complete squares. This can be 10 units squared. But if we look at the next polygon down at the bottom here, and we try to figure this one out, this is a little bit different. We've got a lot of angles to deal with. We have half squares, quarter squares, sixths of a square, maybe eighths, ninths, tenths of a square. It's much more challenging, and we can't estimate. We can maybe ballpark it, but what we really need to do is figure out formula that will help us get accurate measurements. And the reason that's so important, if you're making something in terms of construction, you want to be precise. You don't want the building to fall or the materials you're working with to collapse. So you have to make sure that you're as specific and detailed as possible. So while in the past you might have counted squares, we definitely will be using formulas throughout. Just like in perimeter, which was P equals sum of all sides, today we'll be reviewing formula that are really important and that you need to memorize and know how to use. So the first one, to ensure that you're accurate when you calculate the area of an object, always need to use one of the following formulas. So the ones we have here for squares, rectangles, and parallelogram are pretty straightforward. Length and width with the squares. So if we look here, we have this one. They're all the same. So if we look here, here, and here, and they're all 3 units. So if we do A equals length times width, we get 3 units times 3 units, which gives us 9 units squared. For the rectangle that's here, we can look, and we have 2 sides that are the same. Here, this one is going to be 4 units, and this one is 2, units. And we can see the marks here to identify. And if we go ahead and we calculate this out, A equals I should start with the formula. A equals length times width. Which equals 4 units times 2 units, which is going to give us 8 units squared. Now, with a parallelogram, we work with base times height. Now, what's interesting with a parallelogram, and I'm going to identify it here, we would need the height, and the height is always the dotted line. And so I'm going to add the dotted line in here, and it will make a 90-degree angle, and you can see that here at the bottom, but it is always I signified that way. And this would be 3 units, and the base is 2 units. You could also do the dotted line inside here as well, and sometimes it's marked inside or outside, so just so you're aware of it. But we would then use our formula, A equals base times height. In this instance, it's 2 units times 3 units, which will give us 6 units squared. So those are formulas you should already know and should be comfortable working with. It's when we start working with triangles, trapezoids, and circles that things get a little bit more complex. So when we look at a triangle, the area of a parallelogram can be calculated by multiplying base by height. We just did that. But since a triangle is half of a parallelogram, and you can see that identified right here, we could use the same formula, just divide by 2. Okay, so if I was to calculate this one out, if I just wanted this triangle that I've signified there, I would do A equals base times height divided by 2. A equals we would have a 10-meter base times a 12-meter height. Sorry, let's fix that there. Divided by 2, which gives us 120 meters squared, divided by 2, which is 60 meters squared. So that actually gives us an accurate breakdown. So if we were to look at it, here we can see that we would be able to find the area of a triangle using the formula I just mentioned, which is right here. But that, what if we knew the area? Well, the way it's written here, I'm going to rewrite it a little bit. If I needed to find the base, we could do it this way. We would do base equals area divided by the height times 2. And if we needed the height, we're a little more used to it seeing it written this way. Again, it would be area divided by the base times 2. So we would just take care of what's in the brackets first, then multiply it out. So let's go ahead and use the formula here to solve this. And you'll notice the dotted line is signified by the height is signified by that dotted line, which is right there. And same with this one here. And it's on, one's inside, one's outside, but they both fulfill what we need them to be. So A equals base times height divided by 2, which we would have 8 meters times 6 meters divided by 2, which would be 48 meters squared divided by 2, which gives us 24 meters squared. And with this one, we'd use the same formula again. And notice I always start with that. A equals base times height divided by 2, okay? Which equals, the base is 19 meters times 16 meters, which is the height. And again, one of the things you can do is you can just put B beside this, and you can put H over here. And we could have done that here as well. Again, dotted line is always the height, so make sure you identify. But anyways, back to this one. If we then go ahead and we divide by 2, 19 times 16 is 304 meters squared divided by 2. And 304 divided by 2 gives us 152 meters squared. So again, this is something you need to see and use with all of your formula, because when you're working with the calculations, you need to make sure you follow all the steps and put your units in at the end. Remember, area is units squared. Now this is an interesting one. This is a trapezoid, and it is an isosceles trapezoid. And the reason we can tell is we've got this side length and this side length are equivalent. It's an interesting, how might we go about solving this? Well, what shapes do you see? I see a couple things. First, one thing we could do is we could divide this into a triangle, a square, and a triangle. And we could sort it out in terms of the base, because you see here, this would be 2 meters, the middle would be 4 meters, and this would be 2 meters, and that would add up to our 8, right? So if we had that as 4. So we could do it that way and piece it out. So if you get to a shape and you're like, I don't remember the formula, or I'm not sure what to do, what you can do is divide it up into shapes that you know. Parallelograms, triangles, squares, and rectangles. A lot of the time, that'll solve everything. Okay, but let's see what we can do. So if we go to the next page here, what is the area of this trapezoid? Well, what we can do is we can divide that there. So let's do the triangle. So A equals base times height divided by 2. And if I look, the triangle is 2 by 3. So 2 meters is the base times the height, which is 3 meters, divided by 2. That's going to give me, and I've got a little mistake there. That should be multiply. So that should be 6 meters squared divided by 2. So that's 3 meters. Okay. 3 meters squared. And then we would just do the rectangle that's there. And so we know, I just label this right now, it's 3 meters squared for here. And if I do the rest and do this part and say red, we have A equals length times width, which would give us 3 meters times 2 meters. And I got the 3 from here, 1, 2, 3, so that's 3 meters and the 2 here at 2 meters. And I get 6 meters squared. So if this ends up being 6 meters squared, and I add them together, I get 9 meters squared as a total. And you could do that even if we look at B for a moment. We can do the same thing. We can break that down, that down. Now what's interesting is there's 2 of them. So those 2 triangles are the same size. So what I can do is, I'll do it down here, A equals base times height divided by 2. And then I'm going to multiply that answer times 2 because they're 2, they're equivalent. So I would have a base of 1 meter times 3 meters divided by 2 times 2. That will give me 3 meters squared divided by 2 times 2. And if you look, these are going to cancel. If I divide it by 2, then multiply it by 2, I'm going to get the same answer. So I end up with 3 meters squared for the 2 triangles, right? So I can just signify that the blue is that. And sometimes that's easiest. You can highlight and break it down. Might be easier to even use a highlighter, so I'll go to mine, right? And that means the rectangle on the inside, this will give us our red. Okay, and this one's pretty straightforward because it's a 3 by 3 square. So we have A equals length times width equals 3 meters times 3 meters equals 9 meters squared. If I add the 2 together, I get 12 meters squared. Okay, and we would use the same process down with this trapezoid. The only difference with this trapezoid, if we look at it real quickly, is that this triangle here is 2 by 3, and that this one over here is actually 1 by 3, and that the center is a 3 by 3. So it'd be very close, but the triangles are different, so you couldn't multiply by 2, you'd have to break it down. The point is that there's lots of steps in this, and this is a way to do it, and if you get stuck, I want you to default to this. I want you to use the skills you have and the skills you know to break it down. However, there is an easier way. So as I had mentioned, there is a faster way to break this down. And what you would do, instead of dividing into different shapes, you would use this formula. But there's an easier way to write it, and it would be like this. A equals A plus B divided by 2 times the height. So what that means is we're going to take the 2 bases, the top and the bottom, add them together, divide by 2, and then multiply by the height. And that will give us an accurate calculation. So when we look over here, if we use that same formula, A equals A plus B divided by 2 times the height. This can be, if I go to label this can be A, there's B, and there's the height. I'll do the same thing here, A, E, and the height. So if we just go back to this for a moment, in the first one we have 8 meters and 2 meters. So I'm going to do 8 meters plus 2 meters divided by 2 times the height, which is 5 meters. 8 plus 2 gives me 10 meters divided by 2 times 5 meters, which when I divide that through, I get 5 meters times 5 meters, and I get 25 meters squared. Now, as I'm working through this, you might notice I'm taking care of everything in the brackets. Measurement formulas, one of the things you could always write on the side of the page that would work out for you is BEDMAS. So make sure you take care of your brackets first. It's why we worked on it earlier with order of operations. So brackets, take care of your exponents, then your division and multiplication as they occur. And your addition and subtraction as they occur. Okay. Very important that you keep an eye on that. Now, if we look at this next one, you know, we have A equals A plus B divided by 2 times the height. Let's plug in our values. So we'd have 12 meters plus 8 meters divided by 2 times 10 meters. So this will be 20 meters divided by 2 times 10 meters. That will give us 10 meters times 10 meters, which gives us 100 meters squared. Okay, that's a lot faster and very efficient. But again, you might forget a step, and if you do, you can go back to chopping the trapezoid into common shapes you know, but if you can, use this. Always remember too, I'll signify it again, the dotted line, folks, is always the height. So there's the dotted line there, there's the dotted line there. So now we move to the area of a circle. And what we're going to be using in it, again, is that wonderful mathematical symbol pi, which is 3.14 or 3 and 1400ths. On your calculator, again, it's an infinite value, so it keeps going. So if you use the pi button, your answer will be a little bit different than when somebody used 3 and 1400ths and typed that into their calculator. It's fine either way, it'll only be a small value. Its main thing is that you understand how to use the formula properly. And what we end up doing is when we're working with an area of a circle, we're looking for a couple things. Number one, we're going to be looking for the radius. We need that, okay? And we're going to square that radius. So if you're given a diameter, you're going to have to divide by 2 to get the radius and then work your way through. But it's actually a quite simple formula, as you can see here. Area of a circle is pi r squared. So if we work through a couple of those on this one, and we can work here. I'm just going to skip ahead for a second. Let's look at this question here. It says a cookie has a circumference of 10 inches. A candy bar has a perimeter of 10 inches. Can you be sure which one has more? Well, we want to know the area. Like they're given the perimeter, we want to know the area. So if we look at the 6 here of the cookie, let's go ahead and calculate that. We really just want part of that, which would be 3 inches. And the reason we want the 3 is because we need the radius. So if we go to that, that's going to be 3 inches. I'll just put it like that. So then we would do pi r squared. So A equals, I'll do it over here, A equals pi r squared. We know what pi is, we'll just leave it. But we're going to square 3 inches. So when we square that, we get pi times 9 inches squared. And if we go ahead and calculate that, we end up with 28 and 2700ths. So we get 28 and 2700ths inches squared. Well, let's look at this one then. If we had, if we start working with this one now, and we break it down, what's bigger? And so we need to find the area of that. So we'll do that in blue so it stands out. It'll be A equals length times width, which gives us 4.5. Oops. Which gives us 4.5 inches times 5 inches. When we break that down, we end up with 22.5 inches squared. So it's very clear that the circle, or the cookie with a 6-inch diameter, has actually got a larger value, and the one you'd rather eat. And we can look at it again with this next one, so give a good chance for us to do the area calculations again. This one's at 4, so the diameter equals 4, which means the radius is diameter divided by 2, so I can write that out. Radius equals 4 divided by 2, so I'm going to have a radius of 2 inches. So I need that, so A equals pi r squared. We got pi, and we're going to put 2 inches and we're going to square it. So that's going to be pi, and that's going to give us 4 inches squared. And if we take pi and multiply it by 4, we get 12 and 57 hundredths inches squared. And I've been rounding to the nearest hundredth, as you know. We always round to the nearest hundredth because that'd be the nearest penny. Okay. And now if we do the same thing over here with the small chocolate bar, this one right here, we have A equals length times width. We would have 5 inches times 1.5 inches. Please note that I keep putting the units in. It's very important. So 5 times 1.5 inches, and that will give us 7.5 inches squared. So it's very clear which one's the larger value, okay? But you can't just always eyeball it. You need to calculate it out and be able to prove it as you work your way. Last one, just a couple circles we would work with. If I look here, this one's kind of an interesting one. The first one, we already have the parts we need. We always start with our formula, so A equals pi r squared. We get pi, and then we would have times 9.5 centimeters squared. Now I know 9 times 9 is 81, but it's 9.5. So if I just square that right now, I get 90. It's a little bit higher, so pi times 90 and 25 hundredths centimeters squared. And then I multiply that by pi, and I'm going to get 283 and 53 hundredths centimeters squared. So that's no problem. Straight up calculation, one that we should be comfortable with. The next one over here, so I'll change to red here, is a little bit different. And as I look at this one, the concern that I see here is that I don't have a radius, I have a diameter. So I actually need to change that. So radius equals diameter divided by 2, which would be 12 centimeters divided by 2, which is 6 centimeters. Then I'm good. I can go ahead and do A equals, so we know it's half, right? So it'll be 6 now. And so it'll be pi r squared. Oops. And I would have pi, and if I take it 6 centimeters, we're going to square it. 6 squared's 36 centimeters squared. And so if I do pi times 36, I end up with 113 and 1/10 centimeters squared. So that works out. Now the last one's probably the trickiest one because it's a semicircle. And then the fact that we only have the diameter. So the first thing I need to do is I need to figure out what the radius is. I know you're probably thinking there's another step, and there is, but let's get that one done first. So if I do radius equals diameter divided by 2 equals 25 centimeters divided by 2, that gives me a radius of 12.5 centimeters. So that helps me, okay? The other thing is this is a semicircle, so my formula is going to change. A equals pi r squared, but it's a semicircle, so I'll find the whole thing and divide by 2 to get half. So it's only one more step at the end. So if I have pi and I put in 12.5 centimeters, we're going to square it. Oops. And then divide by 2. I get pi times, and if I square 12.5 here, I end up with 156 and 25 hundredths centimeters squared. And then we're going to divide by 2. So it'll get a little bit easier in a second. If I multiply that by pi, I'd end up with 490 and 87 hundredths centimeters squared, but I need to divide that by 2. And when I do divide that by 2, I end up with 200. I'll put a little arrow up here. 245 and 44 hundredths centimeters squared. The most important thing with this activity and anything that we do is use your formulas, use your formulas, use your formulas. Be precise, take the time to write it out.